Hello and welcome to our monthly Utah Elixir Meetup. Today is May 21st, so this is our May Meetup, and my name is Mark Erickson. So tonight, our presentation will be given by Michael Ries. Michael is an awesome guy, first. He's presented at conferences, he's led a remote nerves meetup, he hosted the Elixir podcast with me for a good long while. He's presented at our meetup multiple times before, and we are fortunate to have him with us tonight. So thank you, Michael, for being willing to share some of the cool stuff you're doing with nerves. And
Yeah, super
go ahead.
exciting to be back, and it's been a few months since I've been able to attend and everything, so it's good to see some familiar faces.
All right, well, go ahead, Michael. Time is yours.
All right, I'm gonna try to do this presentation thing. If anybody could just interrupt me if there's people raising hands or chats, because I may not see that. Let's. Oh man, fun has already begun. All right, we'll try to share this one. All right, let's see if this is working. All right, so yeah, Michael Ries. I'm a CTO at a little startup here in Utah called Spiff. We actually are hiring, we're just about 2 weeks out from really starting the hiring process. But if anyone's out there looking or interested, it would be mostly an Elixir position. It's a pretty interesting domain. It requires a huge amount of flexibility, but also very, very low latency, which is an interesting combination. And we're leveraging a lot of OTP stuff to make that happen, where we're kind of managing state and memory and stuff like that. So lots of fun. It's a good group of people. Hit me up if you're interested. And then I put down here the link to the repo that we're going to be kind of talking about a little bit tonight. So if anyone wants to take a look at that as well, they can. And so without further ado, the topic today is how you can make your own Tesla. And so the step one is acquire a golf cart. This one showed up, a neighbor of mine, we moved houses about a year ago, and one of the new neighbors was like, hey, my kids, the youngest of his kids moved out of the house. And when they had been teenagers, he had kind of fixed up this golf cart once before and used it with them, and they had kind of been driving around the neighborhood on it, and now no one was home, and he's like, I really don't want to fix it up again and do more work on it. Would you and your kids be interested in taking it over? And I, of course, said yes without checking with anyone else in my family, because why would you? And so it turns out that the backstory is this is a 1950s golf cart, and this neighbor's wife's grandfather worked at a golf course where this golf cart was being used until it was rolled off of a cliff and the rear axle is slightly bent. So they gave it to him for free. And you should try to find exactly this scenario. This is the optimal scenario for acquiring a golf cart, by the way. But anyway, you can tell it was in pretty rough shape. So the first little bit of the project then is just taking things apart, and pretty quickly I realized that there's a lot of these old wires. Like you can see, there's kind of tape on some of these wires holding them together. The way that the speed control works is this set of resistors. So when you push on the throttle pedal, this little metal thing on the left-hand side slides along the contacts of these other resistors, and that creates a variable amount of resistance between the battery and the motor. And that means that all the power that's not going into the motor just goes to heat, and your butt gets pretty warm pretty quickly if you're going at slow speeds for very long. And so that was an interesting design choice. And so now the part of the project where you do many things. This meant buying some new batteries, buying new tires. Then the step is breaking many of the new things that you just bought and having to reorder them. I'm sure this sounds familiar for anyone who's done DIY projects. So one good example is I got this electric motor controller. This is using pulse width modulation to control the speed of the motor instead of resistors. And it worked great, and I was able to test it. And then one night I forgot that I hadn't disconnected the battery, and a tool fell on top of two of these terminals. There was a big flash of light, and it was broken. So now you redo many things, but we're really not here to talk about the physical part of the golf cart, as much fun as that was. But really, the thing that makes this project interesting to me is my kids all love it. It's this it's a fun chance to kind of work on some electronics, and it's the only project I've had a chance to work on where like it would be a device in the field. It's not plugged into a router, it's not plugged into a wall. It's going to be kind of out and about, and that sounded like a fun and interesting project. So so what are we going to do with nerves? And for me, this starts with two features I want. I want something that kind of shows the current state of the battery. I just bought a bunch of new batteries, and I really don't want to like run them too low for too long and damage them. So I want some sort of visual indication of my battery status. And then I would also like to have some sort of like passcode entry to the vehicle. Like the motor's not going to spin until you've entered some sort of password. And so I'm kind of looking for these two things. Oh, sorry, someone just asked the link for the repo. Here, I'll get it for you real quick. GitHub cart. And I'll drop it in the chat. So yeah, so these are kind of the two things that, the two features that I was starting off with. So the first question that you really have to ask yourself with nerves, and mainly what we'll be focusing on tonight are sort of like, what are the things that you can do with the nerves project? What are the high level decisions that you might want to think about? I don't have a lot of slides going into detail on any one of these topics, but if anyone's interested, pop up, ask me a question, and we can dive deeper on any one of these. But one of the first things you have to figure out is the whole reason you do a nerves project is that you want something programmable or something intelligent to happen. And that usually means it needs to interface with some other stuff. In this case, interfacing to the battery of the vehicle, that's pretty straightforward. It's going to be powered off the battery, so it's already going to have some connections there. And those will just literally be wires that go between the battery and this. So that's kind of the interface between the nerves device and the golf cart. But what about my interface? How am I going to see the state of this thing? Or how is it going to give me information or allow me to interact with it? So the sort of easiest way to do this in a lot of cases is just to use Wi-Fi. So most of the Raspberry Pis that you can buy, they have a Wi-Fi chip on board. If you do mixnerves.new, give it a name, and then do --nerves pack, it will generate the project with a bunch of stuff included that kind of has Wi-Fi prepped for you. All you do is go into your config.exe file. You put in a couple bits of configuration to tell it which Wi-Fi you're joining. Maybe you do that with environment variables or something if you're going to share the code publicly. And at that point, you're going to do mix firmware.burn, insert your SD card, get that image burned onto the SD card, plug it into your Raspberry Pi, power up that Raspberry Pi, and you can do ssh cart.local, and it's going to find that thing on your local Wi-Fi via MDNS. And so this is like a very low friction. It's sort of built into the framework, batteries included sort of an experience. And if then you generate a Phoenix project that goes along with this, you can do that as like as a vendor library, or by just adding Phoenix to the project. Or a lot of people in the nerves community will do what's called Poncho projects, where your Git repo has two different separate projects, and they just use a path dependency to point to the other one. And so you can just have your nerves project depend on a Phoenix app and boot up that app when it boots. And then you just use something like live view or channels or whatever you want, and you can have a Phoenix app running on that, and now you can use a laptop or a phone on that Wi-Fi to connect and talk. So a lot of times this is sort of your first easiest option, because everything you already know about Phoenix and channels and live view is going to work. So you can then present any information you want. You can take any sort of user input that you want to do, and you can make that all work, but it's physically connected to some other things in your house or your golf cart in this case. So that's a great option. Not such a great option for this particular project, because the whole point of a golf cart is to go some other place, right? Like you don't really drive around in the Wi-Fi range of your home Wi-Fi router. So so joining an existing Wi-Fi, not such a great option for this project. All right, so option number two, you can actually do a Wi-Fi access point where your Raspberry Pi is going to act as its own Wi-Fi hotspot, and you can have your phone join that. And there's actually a project called VintageNet Wizard that was written by the community. John Karstens, if any of you guys jump into the nerves community, you'll pretty quickly come across his name. Great person. and he built this project, and you can basically just do that same like mixed nerves.new, and then you just add the vintage net dependency. You add a couple things to your config.exs file, and you can make this so that when it first boots up, it will actually run its own web server. It can actually do like a captured portal where all port 80 traffic will be redirected to its own server, so that kind of whatever website you try to join, or the first time you, a lot of times like your phone will actually just prompt you and say, oh, you need to log in to this Wi-Fi or do further authentication. And all that stuff just works out of the box with this one library, which is pretty cool. And you can also configure it so that when it sees, it's totally programmable. So you can do things like scan for other Wi-Fis. And if you see a Wi-Fi you recognize, you can actually turn off your hotspot and join that one instead. And then when you get away from that Wi-Fi, you can switch to being an access point. There's all sorts of neat things that you can do with this vintage net stuff. In this case, I didn't love that idea just because I really didn't want to be like switching back and forth. I did actually use this and I got it up and running. And at first I was like this little kid, and I was telling my family like, oh, look how cool this nerves thing is. And it totally works at home and when we're driving. But inside I was sad because it always takes a minute to join the Wi-Fi. And if I join the Wi-Fi of the golf cart, then I can't actually access anything else on the internet, and et cetera, et cetera. There's weird problems with it. So option number 3, this is another great option if you're new to the nerves community. This one's not as kind of out of the box or quite as easy to do because it does require learning some more new stuff. But Scenic, if none of you have heard of it, it's written by a guy named Boyd Multerer. He's given a lot of great talks at ElixirConf and other places. So there's a lot of good introductory material, but this really is a framework that's designed for building UIs when you have a screen that is going to be physically connected to you, wherever your program is running. And it allows you to write really simple UIs where you can receive like touch events. You can display things on that screen. You're not using any HTML, no JavaScript at all. So it's sort of like even less JavaScript than LiveView is the way I like to think of a Scenic project. But you also don't have any CSS, so no help with layout. And you kind of have to do more of that on your own. So some interesting trade-offs there. I have a commit that's linked here in the slides, and these slides are posted in the Utah channel of the Elixir Slack if anyone wants to check them out. But it gives you like, this was an overview of what it took to add Scenic to a project. I did it all in one commit. And if you go look at it, it's like 4 files changed. 2 of them are config files. One of them is the mix.exs file to add the dependency. And then you add one other file that acts as the scene. And so that's going to be sort of like the window that starts up when your application starts. And I happen to have a Raspberry Pi 7-inch touchscreen sitting around. And I really, actually, the more I thought about it, I really liked the idea that just like when you turn on the golf cart, a screen will boot up. And it's just on there. Like, you don't have to use your phone. It doesn't depend on anything else. It doesn't depend on MDNS. There's no like networking. There's no, is my cookie secure issues. It's just a screen, and it's controlled by your Raspberry Pi. So I went with this option, and it's been a lot of fun so far. So what this ends up looking like is there is this place that, I don't know, people maybe put golf balls in here, or maybe those tiny little pencils that golf people always use for whatever reason that they like to write with small writing utensils. But it happens to be right behind where the steering wheel is, so it's kind of a naturally dashboard sort of location. And just on the back of it, you can see there's a mounting point for a Raspberry Pi, and it comes with like the mounting screws and everything. And so I basically just have this Raspberry Pi that's tucked up underneath it. I put it into this little spot. It jiggled around and came loose once, and so since then I just use a little bit of hot glue to kind of hold it in place. But that's the whole thing. And it does attempt to join the Wi-Fi when I'm at home so that I can do over-the-air updates or interact with it. But most of the time when you're driving around, it just is offline and only talking to this touchscreen. So if we zoom in a little bit on the project itself, there's a Raspberry Pi. And initially, the setup looked something like this picture on the right-hand side. I was trying to figure out, how do I both power the Raspberry Pi? So Raspberry Pis need a 5-volt power supply. 5 volts is way too low of a power supply or a battery pack to run something like a golf cart. So you need to find some way to like lower that voltage to a safe level for the Raspberry Pi, but you can't measure the lower voltage because now you don't know what the original battery is. So you actually end up kind of connecting it twice. Again, a lot of the details here are not super interesting unless you're into electronics. And most NERSC projects that I've ever done did not have nearly this many wires in them. This one's a little bit of a branching out experience for me, trying to get my feet a little bit deeper into that pond. But essentially what happens is there's one device here which lowers the voltage, and then there's a separate device where you hook into the original power of the battery, and you connect that to this separate chip called an analog to digital converter chip. And that basically just that will just tell you some sort of like integer number representation of how high or low was that voltage in reference to something else. And so in this case, I can create just a little voltage divider, and I can say what is the voltage of the battery in reference to some other known voltage. And so originally this was sort of just like a bunch of wires hooked together. And I found this great thing on Amazon where there's a breadboard that comes in the shape of a Raspberry Pi. So you can hook a few things to that, do a little bit of soldering, and then when you screw it onto the Raspberry Pi, it just connects to the header pins that come on the Raspberry Pi. So you don't have to, you can kind of like solder all your stuff over here and then just plug it in. And that's now also bolted to the back of that little touchscreen. So this was kind of what we ended up with, is a UI that looks something like this. There's a little bit of debug information, which just was built in when I generated a new Scenic project. And I've just left it there because there's nothing going on that part of the screen anyway. And when I test it locally, I run just a little OTP, a little gen server that just randomly generates numbers between 32 and 42 volts, just so I can see things rendering. But on the actual cart, it's obviously hooked up to the battery. So just to get a little bit of a flavor of how do these what does the code look like in these sorts of projects, we'll look at just a couple small snippets here. So one is, how do you actually read the battery? I talked about how we are connected to that ADS analog to digital chip. And there's a library in the community for talking to one of these ADS 1115 chips. And so this is like a $7 chip that you buy on adafruit.com. And then you install a hex dependency. And now there's this little module where you're going to call new, and it's going to open a connection to what's called the I2C bus. This is like 2 pins that come off of your Raspberry Pi. And they actually act as a bus. So they're kind of like a really simplistic Ethernet cable, meaning that you can connect multiple things all to the same pair of wires, and they can all take turns talking. And there's sort of a low-level protocol for how they decide who's talking when. But you don't really ever care about that as someone building a project. You just know, oh, I'm going to use the I2C wires because this chip talks I2C. So I have those 2 wires hooked up. Whoops, I just put all my screens to sleep. So now I have no idea where I am. All right, back again. So the main thing to notice here is this one is just pure functional module, right? And oh, am I sharing my screen still?
We're not seeing your screen anymore.
Thanks. Yeah, when I put them to sleep, I think it turned off my screen share. All right. So then whenever I want to read the voltage, I use this one function on the ADS 1115 module called read. And I just say, there's like 4 different voltage signals you can read with this chip. And so I say, hey, I want a comparison from the A in 0 to the ground wire. And I'm expecting a value between 1 and 4096. And that's basically how many, the digital precision of this reading. So I do that, and then I use just a little bit of math to kind of convert that integer number to some sort of floating point value that represents a relative voltage level. And then I return that. And obviously, there's a little bit of with logic here, just in case opening the I2C fails or reading from the I2C fails. Obviously things could have come unplugged or whatnot. So you can just return errors in those cases. Then we have just this tiny little gen server. Anyone who's done gen server stuff before, this will look pretty familiar. I have just a little bit of like, hey, if this is, if I'm running this on my host on my laptop, then I am going to use the cart.fake battery. Otherwise, I'm going to use the normal cart.battery, the module we were just looking at. And then when I start up, what I do is I register a sensor. And this is kind of just like a little internal pub sub that the Scenic project has. It makes it really easy to hook to certain components that are just open source in the community. And so I say, hey, I'm going to register a sensor called the battery level and give it a name. And then I'm going to create a new reference to a battery struct. And then I'm going to return with a timeout of 200 milliseconds. And because there's nothing else that this Gen server does, it's just going to get a timeout message in 200 milliseconds. And when it does, all I'm going to do is call this publish voltage, which asks that whatever battery module I'm using, it says, hey, tell me your current voltage. Pattern matches on the success case, it'll just fail and get restarted if an error occurs. And then when I get back that voltage, I publish it. And in this case, I'm actually publishing it twice because I had Phoenix Live View hooked up at one point, and technically that's actually still running and is still available. But really all I need to do here is I just need to like let the rest of the system know, hey, I got a new battery voltage reading. Here it is. Anyone who's interested can update their UI. And then finally, this is pretty much the entire bit of Scenic that runs in this project is all right here. And I've split it into two small groups. So I have a module reference that gets built at compile time, which builds a graph data structure. This is what Scenic uses to keep track of all the little bits that it needs to render. And so at compile time, I just build and I say, hey, I'm going to have one little group, which is a couple of text nodes that give me some system info. I'm going to have a fuel gauge component. This is an open source library. It was one I actually wrote a while ago, but it's on HexPM. And when I add it to the scene or to the graph, I tell it to use that battery level sensor. That's the one that I registered in my battery monitor just a minute ago. And so I'm going to say, hey, create a fuel gauge for me and hook it up to this battery level Scenic sensor. And then I give a little bit of positioning information like, hey, I want you to be pretty big because you're going to take most of the screen in this project. I want to be able to just kind of glance and always see the state of the battery. And then I'm going to translate it, move it over a little bit to the right, move it just a little bit down to kind of get it in the spot of the part of the screen that I like. I'm adding a little text label where I bump up the font size and I give this an ID just so that later I can go change the value of that text node. And similarly, I translate it up to the kind of top right corner. And then finally, I add this keypad component. This one was written by Amos. For anyone who listens to other Elixir podcasts, what is that? Elixir Outlaws. And so Amos published this library, which is great. And it gives you this keypad. And so again, I just kind of position it, scale it. And then really the only other thing that happens in this file, if you take a look at it, it's called the sysinfo.ex. And it's very similar. It has an init function. So when it first starts, it also subscribes to the Phoenix pub sub that was already in place. And then it basically just returns the state of the graph, kind of that initial compiled state of the graph. And then anytime it receives a voltage message, which would come from the Phoenix pub sub, I take in that voltage level. I use the IO-lib to kind of format it to a one digit of precision number. And then I turn that into a little text, a little bit of a string, and I say, hey, I want to modify the battery level part of the graph, and all I'm going to do is replace it with a new text node with that string in it. And so this gives me the ability, like on startup, I'll just render kind of an empty label, and each time I receive one of these voltage measurements, I'll just update that little bit of string. So again, if we take a look at this, the way that this actually looks, that little text label is this thing. So that's what I'm changing each time I receive one of those messages. This, I just hooked it to a sensor, so it's updating itself and just kind of changing the angle of that arrow and kind of rotating it around based on where you're at. And then obviously I'll have some listeners for when I touch on these keys, then I can receive those as messages and decide what to do with those and send them to some other Gen server. So hopefully that gives you a little bit of a flavor. The main thing that I think is a takeaway here is if you've done any sort of Gen server or pub sub stuff before, the stuff you write in Nerves really doesn't feel that much different. It's a different set of libraries, a little bit of a different tool set, But really the Elixir part of it, everything you've learned, everything you know, that transfers just fine. So then at this point, it's really just down to like time to brag to your family about how awesome you are. I did actually, let's see if this video plays. So after this little shenanigan, I actually did get a standing ovation. My kids chanted, "Our daddy's the best," which is like, okay, yes, I am actually officially awesome. Doesn't really matter if I've accomplished anything in my career. I'm pretty awesome at this point. And so, it works pretty well. We're having a lot of fun with it. We drive it around, the neighborhood. We drive it down to pick up the mail from the mailboxes and all that kind of stuff. And just generally, goof around like a bunch of kids. So any questions that people have? I don't know if anyone has nerves projects in the past that they've thought about and they have questions about, what's possible or how to maybe go about something, or any other questions that people have.
I have a random question. Do you happen to know why Scenic uses a graph to represent like the UI?
So I have a very cursory understanding of that. Boyd talks about it in some of his talks, so refer to more expert people. But my basic understanding is that if you can represent the scene, like the current state of the scene, as a data structure, it gives you some really nice abilities to sort of like skip all the rendering cycles when nothing has changed. So in a way, it kind of gives you some of the benefits of like a virtual DOM. If you're familiar with React or other frameworks on the JavaScript side, this sort of gives you that same thing. You can, it's really easy to know if like, hey, nothing changed the graph, therefore I know I don't even need to re-render this time around, and that can save a lot of power, things like that. Awesome. Any other questions?
Well, I had one. I was just curious, what did you have any plans for the keypad? I'm just kind of wondering, what were you thinking would be a fun thing to do with that?
Yeah, so that is it's only in a partial state at this point, but after I fried the one speed control and really scared myself quite a bit, my next project was actually I put in like a master on-off switch on the battery before it connects to anything else in the golf cart so that I can easily shut that off. Lesson learned. But the next speed controller that I bought, it actually has, in order for you to enable the speed controller, you actually have to turn one pin to a high voltage, and it won't allow anything to move. And so generally you would wire this up to like an ignition key or something like that. If this was, a lot of these things get used on like electric scooters or electric motorcycles, things like that. And so normally what you do is you just take the voltage, one of the voltage wires from the battery, and have it go through like an ignition switch or something like that. Actually, back what I initially did back here, let's see, how far back do I have to go? Right here. This little, you can see just behind the screen on that lower right-hand picture, there's an on-off switch. Mm-hmm. That was kind of the next phase of this. So that meant that I could like charge up the batteries and leave it ready to go, but it's not actually using any power from the battery, so it doesn't like slowly drain your battery overnight. And until I flip that switch, it won't send any power. It won't send a wake up signal to the power, the speed controller, and it also won't actually turn on the Raspberry Pi itself. So this means that I can kind of like charge it overnight and leave it ready to go. And when I'm ready to go, I don't have to go fiddle with any wires. I can just hit one power switch. But in order to like get the security just one step past that and have sort of like a lock unlock with a pin code, my idea is to turn that pin high or low based on logic from the Raspberry Pi. And that'll mean that I can have, power is ready to go, but nothing spins until you enter the key code. And maybe once you've entered the pin, then you have like a lock button. So you drive somewhere and then you lock it when you walk away from the golf cart. Realistically, security is not that big of a concern with a huge 1950s golf cart that looks like it should be broken all the time, but it's fun.
Oh, it's awesome. So I did have another question. If you could jump back to the screen where you were showing the cart battery module.
Yeah.
So I was just curious because you mentioned how you were able to, it sounded like there were projects that had ready code for different sensors that you could just kind of pull in like as packages. Is that right?
Yep.
And is that what the, like on line 27, there's the ADS 1115. I was just curious as to, like, is that part of a library that just kind of comes available, or is that something you wrote, or if you could elaborate on that?
Yeah, actually, let me show you a little resource that I find really useful in a lot of these cases. Where did I put my? So if you go to, I think it's called Elixir Circuits. So the community has sort of created just a little repository that tracks a bunch of these projects. And there's a couple of core projects here. So like there's the I2C bus that I mentioned. And so there's kind of a low-level library for talking I2C. There's a similar concept called SPI and another one called UART. These are all sort of different common things that you'll hear, or as like if you just go Amazon searching for like a moisture sensor or a light sensor or something, you'll see these different acronyms. So there's sort of base level libraries that are supported, but then there's also a bunch of things that have been produced by the community. And you can see there's like a wind speed one, a Max 72XX, no idea what that does. Most of these things I've never used all. Grove Base, Herald does Bluetooth stuff. This wafer, let's see, connected peripherals and connecting them with GPIO pins. Anyway, you get the idea. There's a bunch of these things. Like here's one for connecting to a farm bot, XBs, all sorts of different things. So a lot of times if I'm about to start a project and I'm thinking, oh, what kinds of things might I want to connect or be talking to, if I just come here and search for like LCD or like LED lights or something like that, pretty quickly in a lot of cases you'll just find something that's right here, and then I'll just go try to find, if this one says, oh, it's for talking to these kinds of real-time clock modules, then I'll just kind of start my search for a clock with that name in mind, so that I kind of know that somebody's already read the white papers or whatever they had to do, and I can just piggyback off that work.
That's a great resource. Thanks for sharing that.
Yeah, thank you to Frank and other people who build these kinds of things. It's a really good resource for people who are interested in hardware but don't necessarily have a background in it.
Michael, were you? It sounded like you have a background in electronics. You didn't seem to be fazed at all by, like, I would be kind of lost as far as just like the golf cart hooking up to the battery. I don't know, just all that kind of stuff.
Yeah, for sure. The first several projects that I did were much less electronics, right? Like well, actually, so a couple of resources I can share. But when I first got started, I really didn't want to touch any electronics or like do soldering or any of that kind of stuff. So my first 5 projects that I did were all things where you can literally just find a wire that plugs into this thing and plugs into that thing, and you don't have to connect anything. You don't have to figure out any resistors, and there's a long way you can go. There's also a great talk given by Todd Rezadek called, I don't remember the name of the talk. I just remember that he built a project called the Drizzle 2000. Let's see, Todd Rezadek. Here we go.
Yeah, I remember listening to that talk. It was actually really good. He was a really well organized speaker. It was a good talk.
Yeah. So he gave it at one of the Elixir comps. I don't remember which one, but if you go look for Todd Rezadek, you'll find him talking about sprinklers, and that's a great project.
It was Lone Star, I'm pretty sure.
Oh, Lone Star. Elixir. There we go. Nice. So yeah, he did a project. He named his Drizzle 2000. And actually, at the same time that he was building this, that was when the Elixir, the Nerves remote meetup kind of was first getting off the ground. And there was, I think, 4 or 5 of us that all built home sprinkler controller systems at the same time. And we were just getting together like once a month and being like, hey, I think this is the right Amazon part. Does this look like something you guys have done? And we would all just kind of share ideas. He was the only one that he really polished his project up and got it to a good state, and then was able to really share it with the community. So it's a good resource, but this is another one of those projects that like you can do something that will actually be useful to some degree in your real life. You know, you can, if you've ever been like, oh, I wish I could check the weather and automatically set whether or not my sprinklers are going to go off. You know, that's obviously pretty easy once there's Elixir code that's controlling your sprinklers. Or if you wanted to hook up a moisture sensor, or if you just wanted to like automatically kind of ramp up the amount of water based on the time of season. So there's, you know, all sorts of different things that you could choose to do for a project like that. And in this kind of project, you know, by the time he gets it like all packaged into a nice little box, he's done some soldering and stuff for that. But the early versions of it, you can see he's just using what are called jumper wires. And those are like little wires that you buy off of Amazon, and they already have female and male ends that are the exact same size as the pins on a Raspberry Pi. And pretty much anything you find on the internet that's called a breakout board will have those same 0.1 inch headers. And anything you find with that size of a header is just going to plug nicely into these jumper wires. And you can use those, and if you know, just to like connect things together and get things working without really needing to know any details about the electronics themselves.
Cool, thank you. That's awesome.
Sure thing.
Yeah, I remember watching John Karsten talk about connecting all the wires up, and I basically followed his video like word for word and got my sprinklers working, and I was so impressed with myself because I have no electronic experience whatsoever. It was really cool though.
I for sure, you know, like I said, I've been becoming interested in this topic, and I am getting deeper into that world the more I learn. But it's pretty surprising how much of all the electronics things that we interact with really are pretty basic. Like it turns out that the way a sprinkler valve actually works is that it just has two wires, and if there's power going through those wires, it opens. And if there's no power going through those wires, it closes. That's literally the only thing that happens inside of a valve controller. And so if you open up like the controller box that's, you know, maybe it's mounted inside your garage or something like that, a lot of times you'll sort of like see some user interface, some knobs and dials. And most of the time there's a little tab that you can just kind of swing that thing forward. And just on the back side of it, there's going to be a whole bunch of, you'll just see the raw wires that are coming in. And it's just going to be 12 different pairs of wires going to each of the different, you know, sprinkler valves that you have in your yard or whatever. I'll see actually if I have. I think I had some of these pictures pulled out. Let's see. Come on, Google searching capabilities. Make me proud. Right here. So it doesn't look like I have a great picture of the front of it, but this is just like what was right behind the little, all the little push buttons that I did to like set the schedule for my sprinkler system. And like I said, I didn't have to unscrew anything. And all I ended up doing was basically just taking one of these little jumper wires from, so I had one little jumper wire that went to what's called a relay that can handle higher voltages than the Raspberry Pi can. And it means that your Raspberry Pi can just tell it to turn power on or off at this higher voltage. So you have one little jumper wire to that relay, and then you connect one wire from that relay to this thing. And I didn't even disconnect the existing sprinkler controller. I just turned off the power to it and added one more wire connected to it. And when I turned my relay on or off, it would turn that valve on or off. And so, you know, really the electronics for a lot of the things that you see around your life, they're kept extremely minimal for the same reason that any of us keep our code super minimal and we can get away with it. It makes everything nicer and easier, and you can, you know, swap things out more easily. So there's a lot that you can do in the world, not needing to know any capacitance and all that kind of stuff.
So I'm curious how fast your Tesla cart goes.
I actually would like to hook up a speed sensor to it. Still looking into ways to do that. I'll provide an update in the channel later on when I get it working. My best guess is there's a downhill road in my neighborhood, and I bet you it probably hits like 13 or 14. It's basically just about as fast as my kid's running, which I probably shouldn't know. And then on flat surfaces, it's maybe like 9 or 10.
And how long are you able to drive it between charges and stuff?
So right now the battery lasts around 45 minutes of straight driving. And that's mostly because so I adopted it without asking anyone's opinions. But then in order to actually like do anything with it, I did want to check in with my wife and talk about how much money I was going to spend on this project. And she definitely had that skeptical look in her eye, like, is this thing ever actually going to drive? Which is a fair question. Definitely, I've had my fair share of projects that never worked. But I was kind of like, well, I think I could just buy this many batteries and this one speed controller and probably have a workable thing at that point. And so I really bought like, if I had bought any smaller battery pack, then how much power it draws, like, if you're trying to start on an uphill, it would draws enough power that it would really damage a pack that's any smaller than the one I bought. But the nice thing is all of those batteries stacked together, they take up almost no space. They're about 10 pounds total weight compared to like if you put lead acid batteries in there, it'd be around 200 pounds. And so definitely a lot of room. I could definitely add more capacity there. But it turns out that we all get bored before we run out of power most of the time. So we haven't extended that capacity at all. The performance model it'll be released after the standard range. Awesome. Well, thank you guys so much for letting me share my project. I always have a lot of fun. If anyone is ever interested in, looking into any NERVS project, or you have an idea and you're not sure, what components you need to buy or whatever, there is a Twitter account called NERVS Meetup, and a bunch of us. Our last meetup, we had 2 friends from Japan, 1 friend from Argentina, and people from 4 different states in the United States, all on a Zoom call. And everyone on the call was some different level of amateur. But everyone at this point has done a good number of projects, and I never fail to find an answer when I have run into a question. So feel free to hit that group of people up. Very friendly, and they're always interested in what projects other people are building. So if you're ever curious, just reach out to us.
Awesome. Thank you, Michael. I really appreciate that because so there's some interesting questions that it brings up for me. And because I can just imagine, well, maybe this could be like your commuter vehicle, because like right now, maybe it's just, oh, I'll take a spin around the block and then go back into my house and get to work. But yeah, so do you let the kids drive it at all?
Yes, for about 2 days. And then one of them crashed it into the back porch.
Oh, no.
Because his brother was chasing him and he was looking at his brother instead of looking forward. So right now, none of them are allowed. I'm pretty sure that there is an interface on that new speed controller that I can actually provide a limit on it. So I am interested in potentially, again, maybe like 1 pin code unlocks 14 miles an hour performance mode and the other one unlocks like 5 miles per hour or something.
So that's cool. You could have like a governor built into it.
Yeah.
That's great. I love that. Yeah. So do you have any idea what, like from the 1950s, was it just a car battery? Like what kind of power did they have in these vehicles before?
Yeah, there's definitely like golf cart specific batteries. But if you look at them, a lot of them are produced by the same people who produce car batteries. And they pretty much just look like the bigger size car battery that you put into like an RV or something. And a lot of people who work on golf carts, they just buy secondhand car batteries and put them in their golf cart. So, like in this golf cart, it's rated for 36 volts. So they'll just take 3 of those 12-volt car batteries and wire them up together. And now that's your 36 volts that goes to the motor.
Wow. That's cool. Yeah. So thank you, Michael, for coming on and sharing this information and just taking your time and sharing it. Appreciate that. So we would love to hear from you, dear listener and viewer. What kind of topics would you like to hear about for next meetups? And we're also looking for volunteers, anyone who's interested in sharing cool stuff that they're working on, be it Elixir, Phoenix, Nerves, anything in that space. We'd all love to see kind of what you're doing, and we'd love to hear about that. So if you're in the Utah area, we also encourage you to join us on the Elixir Slack Utah channel, where we kind of hang out, and it's pretty quiet, but we're always around and in there. And if you have questions, there's several people who will jump up and try and help you out. So that's it. I didn't see any questions that we didn't already address, I guess, in the live feed. So thank you for coming and viewing with us today, and we'll catch you next time.